Transformers are electrical devices consisting of two or more coils of wire used to transfer electrical energy by means of a changing magnetic field. One of the main reasons that we use alternating AC voltages and currents in our homes and workplaces is that AC supplies can be easily generated at a convenient voltage, transformed into much higher voltages and then distributed around the country using a national grid of pylons and cables over very long distances. The reason for transforming the voltage to a much higher level is that higher distribution voltages imply lower currents for the same power. These higher AC transmission voltages and currents can then be reduced to a much lower, safer and usable voltage level where it can be used to supply electrical equipment in our homes and workplaces, and all this is possible thanks to the basic voltage transformer. The voltage transformer can be thought of as an electrical component rather than an electronic component. A transformer basically is a very simple static electromagnetic passive electrical device that works on the principle of Faraday's law of induction by converting electrical energy from one value to another. The transformer does this by linking together two or more electrical circuits using a common oscillating magnetic circuit which is produced by the transformer itself. A transformer operates on the principles of electromagnetic induction, in the form of mutual induction. Mutual induction is the process by which a coil of wire magnetically induces a voltage into another coil located in close proximity to it. Then we can say that transformers work in the magnetic domain, and transformers get their name from the fact that they transform one voltage or current level into another.